And I'll read it again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so now, today we're going to start chapter 7. We're going to look at 2 sections today. We're going to continue to use this whole idea of factoring. So if you thought factoring was done, we're just getting started. Woo! Everybody's excited about that, I can tell. All right. So we're going to take a look at section 7.1. Oh, if you have any questions about your test, email me and I'll contact you personally and go over questions with you if you want, but I'm not going to do that during these sessions. Okay, let's say we have the expression 3x minus 2 divided by x minus 2. And we are to evaluate this expression for x equals 6, okay? X equals 6. So that would give me 3 times 6 minus 2 over 6 minus 2, which is 18 over 18 minus 2, or 16 over 4, which is 4. Any questions about that?
No.
Forward there. All right. What if we had this expression? X squared minus 36 over x cubed minus 1. That would get, and again, we're going to use x equals 6. So we'd have 6 squared minus 36. That's a little longer than it needs to be. Over 6 cubed minus 1, which is 36 minus 36, which is 0 over, let's see, 6 times 6 is 36. Let's see, 6 cubed is, whoops, let's try that again. 6. 216. Is that what you said?
Yes, from my calculator.
Yeah, I kept pushing the wrong buttons. I'm doing great. It's a Monday. You know how that goes. Okay, so we get x equals 0. So, or rather, we get the expression equals 0 for x equals 6. All right. And now let's take a look at this one. Negative 2x squared minus 3 all over x minus 6. And again, we're going to evaluate the expression for x equals 6. So we're going to get negative 2 times 6 squared minus 3 over 6 minus 6, which is negative 2 times 36 minus 3 over 0, which is negative 72 minus 3 over 0, negative 75 over 0. But what is dividing by 0?
0.
Oh, no. Undefined. Remember, you can't divide by 0. The universe collapses. Bad things happen. You don't remember that? If you have 0 divided by a non-zero number, that's equal to 0. But a non-zero number divided by 0 is undefined. We okay with that?
So could you repeat that again? Anything?
Okay.
Say it again.
0 divided by a non-zero number is 0. A non-zero number divided by 0 is undefined.
Okay.
So dividing by 0 is undefined. You can't do it. So watch out. All right? Okay. Now, the directions say, for this next problem, find all real numbers for which the rational expression is undefined. So 5x over x plus 5. So for what value or values of x would this expression be undefined? Well, dividing by 0 would make it undefined. So when would x plus 5 equal 0? When would x plus 5 equal 0? When
It's
x
-5.
equals -5, right? And what you could do is you could just take this equation and solve it for x. So back up here, let's see, it says for find all real numbers for which it is undefined. So you'd say for x equals -5, because when x is -5, the denominator is 0, the expression is undefined. All right. So here they're asking you to find the number or numbers that make it undefined. How about this one? 4x minus 1 over 6x. For what what real numbers, if any, would make this thing undefined? For what value of x or values? When would the denominator be 0?
You could multiply it by 0. No, -6.
Nope. 6 times -6 would give you -36. Here, if x is 0, 6 times 0 would be 0. So that's the value. Okay. Now, how is that different from the last one? Here, we were adding. Here, we're multiplying. 6 times 0 is going to be 0. So if x is 0, the denominator is 0. Are you seeing the difference there?
Yes.
Okay. How about this one? X squared minus 4x over x squared plus 4. It says find all real numbers for which the rational expression is undefined. So are there any values of x for which the denominator would be 0? Could a real number squared ever equal -4? Could a real number times itself ever equal -4? What's negative times negative?
Positive.
What's 0 times 0?
0.
What's positive times positive?
Positive.
Could a real number times itself ever equal a negative number?
No.
So there are none. There are no values of x that would make this thing undefined. Because if you put in a negative, negative squared is positive, positive plus 4 is positive. If you put in a 0, 0 squared is 0, 0 plus 4 is positive. If you put in a positive, positive squared plus 4 is still positive. So there's no restrictions there. It's Monday, isn't it? All right. How about this one? Any real numbers for which the rational number is undefined. So again, when would the denominator be 0? When would that be 0? Well, when x is 1/3. 3 times 1/3 is 1, 1 minus 1 is 0. So basically you're taking the denominator, setting it equal to 0, and then solving it, if you can. Back here, there was no real number solution, but here it was 1/3. Okay. Any questions?
So we don't do anything with a numerator?
Nope. 0 on top's okay. It's dividing by 0 that's not okay.
Okay.
0 on top, that's okay. It's dividing by 0 that causes the trouble. Oops. All right. Now, simplify the following expression. 45 over 9a. Can we do anything to simplify that?
Yes, take out 9 or divide.
Okay. What's 45 divided by 9?
Is it
5, isn't it?
Okay. What's 9a divided by 9? Give me a good Canadian answer.
A?
There you go. Okay. If you need to see that in a different light, there's doing it out, writing out all the little details. We're taking a 9 out of the numerator and the denominator, reducing it down to 5 divided by a. Okay. 9x cubed over 6x. Can we simplify that?
Yes, with a 3x.
Oh, so take a 3x out of both?
Mm-hmm.
All right. And again, let's just do it this way. We don't have to do it this way, but so you're taking out a 3x, so you're going to get 3x squared over 2. Or you could just do it like this and say, well, 9 over 6 is 3 over 2. X cubed over x is x squared, so I've got 3x squared over 2. Long way, short way, either way. All right. Now be careful. This is where the trouble starts. Can you reduce this?
No, right?
You can, but be careful how you do it. You can't say, well, 4x over 16 is x over 4, or 12 over 16 is 3 over 4, because these are terms. You can't reduce terms on top with factors on the bottom. But what you can do is factor out a 4 on top. So now the factors of the top are 4 and the quantity x plus 3. And the factors on the bottom are the 16. So 4 over 16 reduces to 4. So we get x plus 3 over 4. But you can't reduce just that one or just that one. Okay? You can reduce factors, one from the numerator and one from the denominator, but you can't reduce terms. 4x is a term of the entire numerator, but here 4 is a factor of the entire numerator. That's the biggie in this chapter, is recognizing the difference between factors and terms. Let's take a look at another one. 2x minus 14 over x minus 7. I cannot take 2x over x and reduce it to 2, because the 2x on top is not a factor of the entire numerator, and the x on the bottom is not a factor of the entire denominator. I also can't take negative 14 over negative 7 and reduce that down to 2 for the same reason. But if I take the numerator and factor it like that, now the numerator and the denominator share a common factor, and the final answer is 2. You can't reduce terms, you can reduce factors. So the idea here is factor the entire numerator, factor the entire denominator, reduce out common factors. Are you seeing what's going on there?
Yes.
Good. Okay. Y squared minus 25 over y squared minus 3y minus 10. So again, y squared is a term, minus 25 is a term, y squared is a term, minus 3y is a term, minus 10 is a term. But if I factor the numerator and I factor the denominator, I can reduce out common factors and get a final answer. So you can't reduce those. You can't reduce those. This is a term, this is a term, this is a term, this is a term. But over here, all of this is a factor of the entire numerator. All of that is a factor of the entire numerator. All of that is a factor of the denominator, etc. So those common factors can be reduced out. Now, y plus 5 over y plus 2, that we're done. You can't reduce the y's because this y is not a factor, it's a term. This y is not a factor, it's a term. All right? You can reduce factors, you can't reduce terms. You're going to be really sick of hearing me say that, but that's the big deal. Okay. X squared minus 10x plus 21 over x squared minus 3x. We're going to factor, factor, factor. Factoring the numerator, x minus 3 times x minus 7. Factoring the denominator, taking out the greatest common factor. So what's the common factor of the numerator and the denominator?
X minus 3.
So we're left with x minus 7 over x. Can I reduce that? No, because the x in the numerator is not a factor of the entire thing. The x in the denominator is, but they've got to both be factors. So there's your final answer. All right with that?
Yes.
Okay. Let's see here. 9y squared minus 12y plus 4 over 3y minus 2 cubed. If I factor the numerator, I get 3y minus 2 times 3y minus 2. So I've got 3y minus 2, the quantity squared, over 3y minus 2, the quantity cubed. Well, let's go back for a minute, back to the beginning of chapter 5, which we didn't cover this quarter, but it was supposedly in your beginning algebra course that you took. If you've got x to the 7th over x to the 4th, that's x to the 3rd power, right?
Yes.
If you've got x to the 4th over x to the 7th, that's 1 over x to the 3rd power.
Yes.
If you've got x squared over x cubed, that's 1 over x. Okay with that?
Yes.
So what's this going to be? It's going to be 1 over 3y minus 2, because you've got 2 of them divided by 3 of them. So you're going to have 1 of them downstairs. All righty?
Yeah.
Okay. Now, there's a pattern, and if you can see it, it makes life much easier. So let's see if you can see it. 7 minus 3 over 3 minus 7. What's 7 minus 3?
4.
What's 3 minus 7?
Negative 4.
What's 4 divided by negative 4?
Negative 1.
10 minus 6 over 6 minus 10. Oh, you know what? I need to use different ones because we're going to get the same numbers, and I don't want the same numbers. Okay. 12 minus 5 over 5 minus 12. There we go. Okay. What's 12 minus 5?
7.
What's 5 minus 12?
Negative 7.
What's 7 divided by negative 7?
-1.
In each of these cases, aren't we getting a number divided by its opposite?
Yes.
Okay. Here's the pop quiz. What's cat minus dog divided by dog minus cat?
-1.
Good job. You got it. How about the rest of you? See the pattern? A number minus another number, and then you switch them. Your two answers are opposites, so you get -1. So cat minus dog is going to be the opposite of dog minus cat. A number divided by its opposite is -1. So what's x minus 3 over 3 minus x?
-1.
What's 2x minus 5 over 5 minus 2x?
-1.
There we go. All right. -1. Yes. Okay. Now, what's x minus 1 over 1 minus x?
Also -1.
Good. What's x minus 1 over x minus 1? Careful.
1.
1. What's x plus 1 over x plus 1?
1.
What's x plus 1 over 1 plus x?
Would that be 1 as well?
Yes. Addition is commutative. Those last two problems are the same.
Yeah.
What's
Yeah.
x minus 1 over 1 plus x?
-1.
Nope. That's just x minus 1 over 1 plus x, or x minus 1 over x plus 1. That just doesn't reduce because they're not opposites. They're conjugates.
The answer would just be x minus 1 over 1 plus x.
Yes.
Oh, okay.
So,
So when would you use, like, you would only use undefined if it was a 0?
in the denominator, right, right. But this is the pattern where you get this, okay? But make sure you've got that pattern, because these other cases, you don't get that, okay? How about this? 18 minus d over d minus 18.
-1.
Good. How about this? 5t minus 1 over 3 minus 15t. Watch. This is 5t minus 1 over 3. And then this is 1 minus 5t. All right? See what I did there in the denominator? Factored out of 3.
Yes.
But then this and this are -1. So I get -1 over 3, because there's that pattern, but there's still a 3 left over. How we doing? Still got a
So
poll?
how would you know which one to put the negative on?
Doesn't matter. You can write 1 over -3, but if you have 1 over -3, when you simplify it, you either move it to the top or out front. So you could put it initially either place. Since ultimately you're going to want it in the denominator or out front, I would just put it in the denominator. I mean, in the numerator. Ultimately, you want it in the numerator, the negative.
Okay, because I would have done -1 times 3 and gotten -3 and not -1/3.
Well, okay, but let's go back here. Okay, so this over this, you would have put like this. You would have put the -1 in the bottom.
Yeah, that's why I was asking. I wouldn't know which one to put it on, the numerator or denominator.
But there's still a 1 in top. So you wouldn't get -3, you'd get
Oh,
1
that's
over
right. That's right.
-3.
Yeah.
And then you could move it up top, okay?
Yeah.
Yeah, careful. The top doesn't become 0, it becomes a 1. All right, let's see how we doing here. 4 minus b over b squared minus 5b plus 4. So this is 4 minus b. And then here we're going to have minus 4 minus 1. Okay. You see how I got to that second step?
Yes.
Yes.
So this is going to be negative 1 over 1. So now I've got negative 1 over 1 times b minus 1. All right. So you want to look for that pattern. Okay. Let's go on. X squared plus x minus 6 over x squared minus x minus 2. Again, I can't reduce out the x squared over the x squared because they're terms. I can't reduce the x over the x because they're terms. I can't reduce the 6 over the 2 because they're terms. But I can factor the numerator. Let's see, this is going to be what? Plus 3 minus 2. And I can factor the denominator, minus 2 plus 1. And now I can reduce out the common factor and end up with that. Again, are you seeing how that's working?
Yeah.
Yokies. This one. 2x squared minus 8 over 3x squared minus 5x minus 2. All right. On the top, I can take out a 2. But now I've got the difference of 2 squares. Okay. So I factor the numerator completely. To factor the denominator, let's see. A is 3, B is negative 5, C is negative 6, the product is negative 18, the sum is negative 5. Let's see. 9, and is that right? Oh, C is negative 2. Where did I write negative 6? I was multiplying ahead of time. My bad. C is negative 2. Product is negative 6. The sum is negative 5. So how about negative 6 and 1? Would that do it? Did I leave all of you in the dust?
No, I was just writing down after you.
Okay, okay. So then this is what? 3x squared minus 6x plus x minus 2. 3x, x minus 2 plus 1, x minus 2, x minus 2, 3x plus 1. So I get x minus 2, 3x plus 1, x minus 2, 3x plus 1. So what's the common factor that I can get rid of?
X minus 2.
Correct. So final answer, 2 times x plus 2 over 3x plus 1. Or you could write 2x plus 4 over 3x plus 1. Okay. So what are we doing? We're factoring the numerator and the denominator, reducing out common factors. Let's see here. We're going to go ahead and go on to section 7.2. Now we're going to multiply or divide polynomial fractions or rational expressions as they're called. So let's say I've got 2 over 7 times z over 3. Well, to multiply fractions, you multiply straight across, unless you can reduce something out ahead of time. In this case, there's nothing we can reduce out ahead of time, so we get 2z over 21. And let's see, what about this one? 11m over 21 times 14 over 55m cubed. Now, again, we could multiply straight across, but it would be easier to reduce first rather than multiply and then reduce. The 14 over the 21 is 2/3. The 11 over the 55 is 1/5. And m over m cubed is 1 over m squared. So I have 1 times 1 times 2 over 3 times 5 times m squared. Lovely. You okay with that?
Yeah.
All right. Let's see. A minus 9 over 9 times 8a over a minus 9. So the common factors, a minus 9, reduce down, and we're left with 8a over 9. Okay. How about this one? Y minus 3, the quantity squared, over y minus 5 times y minus 5 over y minus 3. We could reduce out the common factors there. Y minus 2 squared over y, y minus 3 squared over y minus 3 to the first power. I've got 2 factors up on top and 1 on the bottom. So I've got y minus 3 over 1, or just y minus 3. Everything else reduced down to 1. Still doing okay?
Yes.
All righty. Let's see here. How about 9p times 10 over p? The 9 and the p, where are they? Are they in the numerator or the denominator?
Numerator?
Yeah, so it's like this, right?
Yeah.
So the p on top and the p on the bottom would reduce down, and you're left with 90. Okay. So here, the 28 and the 4 reduced to 7 over 1. So I've got 7 times 8 minus 3t over t, or 56 minus 21t all over t. But I can't reduce the t on top and the t on the bottom because the t on the top is not a factor of the entire thing. The 7 is, this t is, but this whole thing, 8 minus 3t, is a factor, but the individual parts, the 8 or the minus 3 or the t, they aren't factors of the entire thing. Division. 3 over a divided by 9 over 5. Dividing by a number is like multiplying by it.
Physical.
Reciprocal. Yeah. I got to be careful that my nines and my a's don't look alike. So I've got what? Oh, I could reduce 3 and 9 to 1 over 3. So I've got 5 over 3a. We good?
Yes.
21x over z squared divided by 7x cubed over z to the fifth. So that would be 21x over z squared times z to the fifth over 7x cubed. Dividing by a number is like multiplying by its reciprocal. So now z to the fifth over z squared would be z cubed. 21 over 7 would be 3 over 1. X over x cubed would be 1 over x squared. So we end up with 3z cubed over 1x squared. We good?
Okay, so when you multiply the powers, you subtract it?
Okay, when you multiply the powers, you add. We're dividing the powers. So hang on here. Let's take a look at this. Z to the fifth over z squared is z to the 5 minus 2, or z cubed. Okay,
Yeah.
let's take a look at that. X over x cubed is x to the 1 minus 3, or x to the negative 2, but then you can put it on the bottom and change the sign of the exponent. Or you can just go straight there and say, well, I'm going to get rid of 1x on top, 1x on the bottom, so I'm going to have 1 over x squared.
Okay.
All right. Refresher course of chapter 5 is what this is. All right. Let's see here. Black. I need. How about this one? B squared minus 5b plus 6 over b squared minus 10b plus 16 divided by b squared plus 2b over b squared minus 6b minus 16. So before I factor anything, I'm going to change division to multiplication of the reciprocal. So I'm going to get b squared minus 5b plus 6, b squared minus 10b plus 16 times b squared minus 6b minus 16 over b squared plus 2b. And I got to make sure my 6's and b's don't get confused. So factoring this, I get b and b, and minus 3 minus 2, product is 6, sum is negative 5. Factoring this, I get b and b, minus 8 and minus 2, product is 16, sum is negative 10. Factoring this, I get b and b, minus 8 and plus 2, product is negative 16, sum is negative 6. And here I'm just going to factor out a b and have a b plus 2 left. And now it's reduction time. Let's see. Oh, b plus or b minus 8 and b minus 8 reduces down. B plus 2 and b plus 2 reduce down. B minus 2 and b minus 2 reduce down. So what have I got left? Up on top, I've got b minus 3. On the bottom, I've got b. And I can't reduce those b's because up on top, the b is not a factor. B minus 3 is a factor, but this is not a factor. This one is, but they have to both be factors of the entire numerator and entire denominator to reduce them out. All right. Let's see here. How about this one? 9b cubed over b squared minus 8b plus 16 times b minus 4, the quantity raised to the 4th power, over 15b to the 8th. Okay. Well, really, everything's pretty much factored out except this one, and that's going to be b minus 4 times b minus 4, or b minus 4 squared. Okay. 9 over 15, I can take out a 3 and get a 3 here and a 5 there. B cubed over b to the 8th, I can get a 1 on top and a b to the 5th. You got 3 on top and 8 on the bottom. You take 3 off the top, 3 off the bottom. You still got 5 on the bottom. And then b minus 4 to the 4th over b minus 4 squared would be b minus 4 squared. So in the numerator, I've got 3 times the quantity b minus 4 squared. And in the denominator, I've got 5b to the 5th. Good to go on that one?
Yes.
Okay. Let's see here. N squared minus 9 over n squared minus 3n divided by n plus 3 over n squared minus n. So that would be n squared minus 9 over n squared minus 3n times the reciprocal, n squared minus n plus 3. But that would be n plus 3 times n minus 3. That's that. This would be n times n minus 3. This would just be n plus 3, and that would be n times n minus 1. Let's see. Those will reduce down to 1 over 1. Those will reduce down to 1 over 1. Those will reduce down to 1 over 1, and I've got n minus 1. All righty. Let's see here. How about this one? Y minus 3 over y divided by 3 minus y over 3y. So that would become y minus 3 over y times 3y over 3 minus y. This y and this y reduced to 1 over 1. What about this and that? What does that reduce down to?
-1.
Right, so in the numerator, I've got -1 times 3, and in the denominator, I've just got 1. So final answer, -3. All right. And another one. The fun just keeps coming, doesn't it? X squared minus 5x plus 6 over 2x minus 4 divided by 2x minus 6 over x minus 2, which becomes x squared minus 5x plus 6 over 2x minus 4 times the reciprocal x minus 2, 2x minus 6. X squared minus 5x plus 6 becomes x, and x minus 3 minus 2, product is 6, sum is -5. 2x minus 4, we factor out a 2 and we get x minus 2 left over. X minus 2 is still x minus 2. 2x minus 6, we factor out a 2 and get x minus 3 left over. Let's see. I could cross these out, or I could have done this one, but I can only do one of them, so I'll do those. And then those. So I've got what? X minus 2 over 4. All right with that?
Yes.
So for tonight, you're going to do 7.1 and 7.2. And I'll be back at, oh, sorry, go ahead. What?
Two homeworks or they're combined?
You know, I don't remember off the top of my head. I think they're written separately. Let's see here. Yeah, I'm pretty sure they're separate, but they're both due like by tomorrow night kind of thing. Okay.
Okay.
All righty.